Hi, welcome to Math After Hours with Miss Austin. I'm Miss Austin, a licensed math teacher, here to help you with your math questions. Today we are looking at matrices again, and I'm going to show you how to solve a system of equations by putting an augmented matrix into row echelon form using Gaussian elimination. That was a lot of words, so you might be panicking a little bit, but it's fine, because that's why I'm here, to show you how to do it. So what you want to do is, if you start with a system of equations like this, you're going to create the augmented matrix first. And to do that, you're going to put the coefficients of your equations on the left-hand side. So first equation, our coefficients are 1, 2, and 1. Second equation is 2, 1, negative 1. Third equation is 1, 1, negative 2. Now, sometimes you'll see a solid line or a dashed line down the middle here. I like a solid line myself. And then you'll put your constants on this side, 8, 1, negative 3. So that is what your augmented matrix looks like. Now, the goal, if I bring us up here, is to have our matrix look like this. This is row echelon form, where you have ones along the diagonal and zeros below. And then what you can do is use back substitution to find the values for x, y, and z. So if we want to turn that into row echelon form, you'll notice that we have a 1 in the top left-hand corner already. That's really nice. What I want to do then is get zeros below. So that would be our next step. So I'm going to start with this one right here. So we're going to use row operations. This is similar to if you were solving a system of equations with elimination. That's when you're adding equations together to completely get rid of a variable. We're doing that same thing, but in matrix form. So how could we use these rows to get a 0 there? Well, if you look right above it, we have a 1. I'm not changing that row yet, but what if I could change that number to a negative 2 and add these two together? That way I could get a 0. So what we would do is multiply the first row by a negative 2 and add it to the second row, and we're going to use that to replace just the second row. So that means that in my new matrix, row 1 and row 3 are not changing. It is just row 2 that is changing. So this will still say 1, 2, 1, 8. Row 3 is still 1, 1, negative 2, negative 3. If I take row 1 and multiply it by negative 2, that gives me negative 2, negative 4, negative 2, negative 16. And I want to add that to row 2. And row 2 is 2, 1, negative 1, 1. So I add these rows together and I get 0, negative 3, negative 3, negative 15. And that is my new row 2 that I'm going to stick in this matrix. So now we are one step closer to where we want to be. We have a 1 in the top left and a 0 below it. Now I'm going to move on to this one right here. I want that 1 to also be a 0. We can't multiply this 0 above it by anything, because anything multiplied by 0 is 0. So I'm going to use row 1 again to help me with row 3. So what if we just did row 1 minus row 3? So I'm going to do row 1 minus row 3, and this time this is to change row 3. So from the previous matrix, row 1 is staying the same, and this time row 2 is also staying the same. We're just going to do row 1 minus row 3 to get that new row 3. So 1 minus 1 is 0. 2 minus 1 is 1. 1 minus a negative 2, that's really 1 plus 2, that's 3. And then 8 minus a negative 3 is 11. Okay, our first column is good to go. We have a 1 in the top left and zeros below it. The next thing I am going to move to is this number right here. We want 1s along the diagonal, and I would love for that to be a 1. So we need to figure out some sort of combination to make that a 1. At this point, you need to always use rows 2 and 3 together. And that's because both of those rows start with a 0. And so when you add them together, it will stay a 0. If you try to use row 1, you will start undoing the work that you already did. And I have students do this all the time. This is where they get stuck because they start undoing the work by trying to use row 1 again. At this point, you have to do a combination of rows 2 and 3. Okay, so I have a 1 in this spot, so I could use that to help me. What if that 1 was a 4? Then when I add it to that -3, I'll get a positive 1. So what I'm going to do then is 4 times row 3 added to row 2 to change row 2. So row 1 is staying 1, 2, 1, 8. Row 3 is staying 0, 1, 3, 11. And I'm going to do this math off to the side. So I'm going to have 4 times row 3, that's 0, 4, 12, 44. And I'm adding that to row 2, which is 0, -3, -3, -15. So that gives me 0, 1, 9, and then 44 minus 15 is 29. So this row is 0, 1, 9, 29. And here we are, one step closer. All of these numbers are now what we want them to be. So now what we want to do next is make this number a 0. We started with the 1 in the top left and got zeros below it. Now we're doing the 1 in the middle, get a 0 below that, and then we can finish with the 1 in the bottom right. So again, we are using rows 2 and 3 at this point because if you try to use row 1, you will undo some of the work we did. But how about we just do some subtraction here? 1 minus 1 is 0. So I'll just do row 2 minus row 3 to change row 3. So row 1, row 2, not changing. So row 1 is 1, 2, 1, 8. Row 2 is 0, 1, 9, 29. And so if we do this math here, we'll have 0 minus 0, which is 0. 1 minus 1, which is 0. 9 minus 3 is 6. 29 minus 11 is 18. So the last thing we need to do to get this in row echelon form is make this number a 1. Now last time when I was getting the 1, we did a combination of the rows and we added them together. Another thing you can do sometimes is just divide the row by a number. You want to be careful with that though, because sometimes when you divide by something, you'll create fractions, and you don't want to have to work with matrices when there's fractions in there if you can avoid it. But on this one, you'll notice we have a 6 and an 18. So I'm just going to do row 3 divided by 6 to change row 3, because both 6 and 18 are divisible by 6. So row 1 is 1, 2, 1, 8. Row 2 is 0, 1, 9, 29. And row 3 would be 0, 0. Now 6 divided by 6 is 1. 18 divided by 6 is 3. Okay, so we have it in row echelon form. We are good to go. Now it is just back substitution. What that means is if we start with this row 3, what this is really saying is we have 0 times x plus 0 times y plus 1 times z, and that equals 3. So that last row gives you your answer for z. So we know z is 3. Now we can use that to help us on row 2. Row 2 is saying 0x plus 1y plus 9z equals 29. So let's plug in that z is 3. That's y plus 27 equals 29. So we subtract 27 and we get that y is 2. Now we can take both of those values and go to row 1, which is our original equation. That is saying that 1x plus 2y plus z is equal to 8. So we'll plug in what we know. That's x plus 2 times 2 plus 3 equals 8. That's x plus 4 plus 3 equals 8. So if x plus 7 equals 8, then x is 1. So the solution to this system is x equals 1, y equals 2, z equals 3. Thank you for joining me today. I hope that was helpful for you. If you have any videos you would like me to do, please comment them below and please like and subscribe. I'll see you next time.